This is the next video, and in this video we will see capacitance in series and parallel. So suppose what we see, the capacitance can be defined as C is equal to Q by V, and it is given in the unit of farad. So if there is 3 capacitors, suppose this is a symbol of capacitor, and if we are supplying a voltage V across it, and the charge on each of the capacitor will be Q, and C1 will be the voltage, C2 will be the capacitance between these two capacitors, and C3 will be the capacitance between these two capacitors. So what we see is that this is a series circuit. So in series, the charge across the capacitor is equal to same, while the voltage applied across the capacitor will be V1, V2, V3. So the voltage will be different and capacitance will be different. So both of these will be something which will be different. So if we see the total voltage by applying the KCL, what we see is that V, if this is a positive terminal and this is a negative terminal, so V will be equal to, or KVL, so V will be equal to the summation of the voltage V1 plus V2 plus V3, and the V can be given by Q by C. This is the first equation, this is the second equation, and the Q by C1 plus Q by C2 plus Q by C3. So this is again will be equal to 1 upon C, all the Q will cancel, and 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the equation of the capacitance, which you will find is 1 upon C equivalent. So C equivalent will be the reciprocal of this. So that's how you are finding the capacitance. So whatever you are getting here, C equivalent will be is equal to the reciprocal of whatever you are getting here. So that's how you are finding the equivalent capacitance when it is in series. Again, there could be a case where there is there are the 3 capacitance, it is C1, C2 and C3. The 3 of them are the voltage across each is supplied voltage is V, so you are supplying that using a battery, and now the charge across the capacitors each will be different in this case, which will be Q1, Q2 and Q3, while the voltage will be V across all, since they are in parallel, and the Q will be equal to Q1 plus Q2 plus Q3, and Q is equal to C into V, which is equal to C1V plus C2V plus C3V. So the capacitance will be equal to C1 plus C2 plus C3. So C equivalent will be equal to C1 plus C2 plus C3, while 1 upon C equivalent, while C equivalent was equal 1 upon C equivalent was equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This was in case of parallel, and this was in case of series for capacitance. So that's all about the capacitance in series and parallel.